Hello, my name is Estefanía Jiménez Montero, and I'm part of the team Quantum 19 from Preparatoria 19, conformed by Ximena, Lizbeth, López, Orozco, and Joel Scott Sánchez Blanco. Um, First, we will share a description of the problem, then our experimental research, and based on that, we will show our hypothesis and our resolution of the problem. Um, well, it is well known that in the air media, a fresh food made on an apple turns brown with time. What are the reasons for the change in color? Experimentally research the dependence of the browning rate upon at least 5 physical and chemical factors. Suggest the hypothesis that explains the observed dependencies. Find out the most effective chemical inhibitor of browning. Propose the effective chemical anti-browner, which can be used without loss to the nutritional status and to the taste of the apple. First, what causes the color change? Enzymatic browning is a degradation process that the apple goes through when it's exposed to oxygen. The polyphenol oxidase reacts with it, and the monophenols of the apple turns to orthodipenols and orthoquinones, and this process ends up in the formation of melanins, and this is why coloration is observed. And now for the experimental task, in order to identify the 5 physical and chemical factors, we made 5 experiments: air exposure, pH, humidity, UV radiation, and temperature. Each experiment was tested in 4 different apple types: Gala, Starkin, Granny Smith, and Golden, and we let run the experiments for 14 minutes. First, pH and standard conditions. We left a piece of each one of the apple types at a table, and we were at the standard conditions of 23 Celsius degrees, and we took a pH proof of the apples. The Golden show a pH of 3, Granny Smith a pH of 4, Starkin a pH of 5, and Gala a pH of 4.5. Now temperature. We compare the pieces of each apple that had been at the standard conditions with one that we put in the refrigerator at -2 Celsius degrees. And the results that we observed were that there was not much difference between both samples. But the ones on the refrigerator oxidated a little less. Then air exposure. What we did was put a piece of the apple inside analytical scales and isolated them from the air. And by preventing the passage of the oxygen, the noticeable browning was considerably less. Now, in humidity, pieces of the 4 types of apple were introduced in water. And by doing this, the noticeable browning was also much less. Now, UV radiation. We left 2 samples of each apple, some in the sun and some in a dark place. And the ones on the sun showed less oxidation than the ones that were not in the sun. Now, our hypothesis is that it is believed that the pH of the apple is the conditioning agent upon which other factors of the browning rate depend, because it predicts color change under different experimental conditions. That is to say, the higher the pH, the greater the dependence of the color change. Because we believe this because in our research, experimentally research, the type of apple Golden was the one with the lower pH and showed the lower browning. Now we need to propose a chemical inhibitor, and the one that we chose was isospintanol, because plants that contain phenol can act as reducing agents and reactants with free radicals. And isospintanol is one of the compounds isolated from the leaves of Oxandra cf. Xylopioides, an onaceae which has antioxidant properties. To understand this better, the mechanism of action of antioxidants is that there are 2 of them. In the first, the free radicals remove a nitrogen atom from the antioxidant, and in the second, the antioxidant gives an electron to the free radical. Isospintanol is a natural compound that has the appropriate structural characteristics, and it has also been proven that it is a better radical scavenger and a better reducer than its biosynthetic analog, that is thymol. Now, there are 3 research methods that can measure the antioxidant capacity of some substances. One of them is FRAP method. This measures the ability of the sample to reduce iron plus 3 present in tripyridilithiazine, that it is organic compound. Then DPPH, because DPPH is a stable violet radical whose absorbance decreases when reduced by an antioxidant. And the last one is TIAC method, the quantification of ABTS radical decolorization. Now, the results that isospintanol and its derivatives showed in these 3 tests is that in the ABTS depends on the bond dissociation energy. In the DPPH, a lower value means a higher antioxidant capacity, and as we can see, isospintanol is the one with this value, the lower. And on the FRAP method is that a higher value shows a greater reducing capacity. In this case, the derivative bond is the one with the best result. Now, about the inhibition of the polyphenol oxidase, we can see that isospintanol and its analogs have great inhibition percentage against the polyphenol oxidase enzyme. So to sum up, isospintanol shows good results in the 3 tests of the capacity of the antioxidants, and this confirms that it is a very effective antioxidant. The compound brominated had a best result by the FRAP test, and the methylated performed better by the PPH test. This means that also its derivative compounds can work, and it is a natural and phenolic product, so it is not cytotoxic and will not alter the nutritional status of the apple, neither the taste. And well, that will be all. Thank you. Thank you for your attention.